Have you ever stopped and thought about where your trash goes after it leaves your house? Maybe you have. See, it gets collected in a garbage truck and then gets dumped in a landfill where it will be stored. Sounds gross, right? But what if we told you that there was an alternative waste management method that many countries are beginning to integrate?
It's called energy from waste, a method designed to burn your waste and turning the heat and extra waste into products such as heating for homes and fuel. In this video, we will inform you about what waste to energy is, the process, the techniques. We also look at examples of waste to energy plants worldwide, if it's sustainable, and district heating.
So what is waste to energy? Waste to energy facilities recover energy and metals from garbage that cannot be recycled. Modern day facilities have minimal effects on the environment and are used worldwide to heat and power homes, recycle metals, and many other ways waste can be transformed into new useful items.
The first incinerator was invented in 1874 in Nottingham, England by Manlove, Elliott & Co. Limited and patented by Albert Fryer. They are known as destructors, not because they were like a cool monster or cool gang name, but because it could destroy waste through incineration.
Here's how the process begins. Domestic waste is collected and brought to a waste-to-energy plant. From there, it's dumped into a large pit. The waste needs to be of uniform quality, meaning that the waste must be well mixed before entering the combustion chamber. Inside the facility, an operator uses a crane to transfer the waste into a combustion chamber, which is where the waste and air, or a type of oxidizer, which is a chemical required to burn fuel, is mixed and burned.
Most incineration plants that are used for treating municipal solid waste most commonly use what's known as a moving grate. The moving grate is timed to turn over repeatedly to keep the incineration process fast and efficient. By incinerating the waste, this creates heat. So while the waste is burning, so is nitrogen oxide that needs to be neutralized as it is very toxic for the environment and our health.
From there, the heat along with the other unburned remains from the combustion travel up and over to a separate side. Most of the unburned remains are bottom ash. The bottom ash is then separated from the heat from the combustion state.
The bottom ash is passed through separators and magnets to remove the iron, steel, and other metals so they can be recycled. What's left of the ash can be used as aggregate, which can be used to help thicken and make concrete.
The heat rises upwards and turns the water into steam in a boiler. The pressure from the superheated steam powers and turns the blades of a steam turbine generator, in the end converting it into energy. The cooled steam from the turbine is then turned into water, then travels back through a condenser and is boiled again, and the cycle continues. But the steam can also be diverted into a heat source and can be used for district heating or even desalination plants.
Mercury, another heavy metal, is highly toxic in the combustion chamber. To neutralize it, they are transported to what's called a spray dryer, where it will be treated with activated carbon.
Once almost everything is treated and is neutralized from the spray dryer, what's left is transported to the boghouse, which is where the smallest airborne fly ash particles are removed by having a fan draw the air through fabric bags towards a stack. The captured fly ash is then returned back to the landfills.
The process of turning waste into energy and a variety of other useful things is certainly not simple and is very costly to build. So is it even worth it to build? Are these huge plants sustainable? Well, compared to the alternative of being in a landfill where the waste just releases methane, waste to energy plants are considered carbon neutral, being that it has a net zero carbon footprint by offsetting emissions by producing energy.
Using waste-to-energy plants are still fairly new to us, and we don't know what the long-term effects of them are or what exactly could be a potential problem. So, is using waste energy sustainable? The short answer is no. While currently it is helping to solve our waste problem, long-term we should be relying on more sustainable, renewable energy, such as solar and wind power.
There are 3 techniques used globally: refined derived fuel, mass burning, and lastly, gasification and pyrolysis. Though the 3 are very similar, they're different in terms of the facilities and end products/results. Diffuse-derived fuel is a less common type of waste-to-energy method. In the end results, in the making of liquid fuel. To do this, they remove metal, glass, and non-combustibles. Then it's burned, creating fuel.
Gasification and pyrolysis, an uncommon method, uses heat to convert waste into synthetic gas or syngas. This can be directly burned for heat or used to generate electricity in an engine or gas turbine. Syngas can also be converted into other products, including biodiesel, green chemicals, and fuel additives like methanol and ethanol.
Last, but certainly not least, the third type is mass burning, the most common and most popular method. This method is used in almost 4,300 facilities worldwide. To do this, they take the waste and incinerating it, collecting the ash as well as using the emissions for district heating.
Burning our waste seems sustainable is offsetting our carbon and carbon footprints. A popular way to offset our carbon level is by using what's known as district heating. So what is district heating? District heating is using a large central boiler to heat houses, commercial buildings, and apartments and complexes.
What many of us today use to heat our homes is a gas boiler, which is a separate unit in each house. This is where using energy from waste comes in, as well as fossil fuels and renewable energy sources. Using the heat from waste is an excellent way to make use of the energy and is what can heat the central boiler, which once the water is heated is sent into insulated pipes.
The water travels underground through these pipes into buildings and houses. From there, it can be used to provide heat and hot water. The cooled water from the houses and buildings is then sent back to the central boiler to be reheated and used again. Using district heating, we will be far more sustainable.
Now let's look at one of the most well-known and newest mass burning facilities in the world. With its modern and environmental architecture, it takes the average idea of a gross factory and revamps it. Yes, we're talking about Denmark's one and only Amagerbakke. This building was created as a mass burning facility and grease space all in one. This one-of-a-kind building includes a downward ski slope during winter, a cafe, a running path, a grove of trees, and what is said to be the world's tallest artificial climbing wall, as well as a recreational area with facilities for water sports, soccer fields, and a go-kart track.
The plant recovers 100 million liters of spare water through flue gas condensation and reuses 100,000 tons of bottom ash, which is used to be repurposed as road material. The plant, which is part of Europe's waste-to-energy movement, is expected to cost 4 billion DKK, which is about 115 million Canadian dollars. Through this huge investment, this project is going towards Europe's waste-to-energy movement, as well as it aids the country to be completely sustainable. The plant will supply 160,000 homes with hot water and will bring power to 62,500 homes, cutting hundreds of thousands of tons of CO2 emissions per year.
On a completely different continent, let's look at Vancouver's waste-to-energy movement. As of 2009, Vancouver had plans to make a $480 million incinerator. Having one already in Burnaby, they were looking for a place to create a new one to aid with waste management. But as of 2017, Metro Canada, the company in charge, put the project on hold, saying that there's no need due to the reduction of waste in the city. Through waste management, the recycling rate has increased by almost 60% from 20% in the past 25 years. Many citizens worry that putting the project on hold may decrease the waste management and recycling rate, but company is not changing their decision of putting the project on hold. There are also many who applaud the project being on hold, due to them believing that a new incinerator could possibly put their health at risk.
Which brings us to our next topic. Are waste-to-energy plants safe for our health? Though this process of converting waste into energy is using state-of-the-art tech, it's not completely foolproof. Most of the concerns come from the excess emissions. Certain plastics release toxic dioxins, which in large amounts can contaminate water as well as contaminating fish and animals that drink the water.
Just like any factories of any sort, whether that be a waste-to-energy factory or not, it's not encouraged or recommended to live anywhere near these facilities. Overexposure can lead to illness and mild cases of cancer. According to the United Nations Environment Program, incinerators are the leading source of dioxin in the environment. The EPA, in a recent study, identified dioxins as the cause of many cancers, the worst component being TCDD, also known as Agent Orange.
There's an easier solution, much simpler than building a huge factory to change waste into energy, but also so much harder to implement by reducing our waste. The world doesn't have an energy problem. We have plenty of that. That's renewable and affordable. The world has a trash problem. problem. We throw out so much garbage every day, most of which can be recycled, donated, or easily composted. The only real way to manage our waste sustainably is to not produce as much of it.
Want to learn more about waste to energy? Check out the website metrovancouver.org in the description, along with a variety of other useful websites. It's a Canadian website that talks about waste to energy, WTE projects, and what's happening in Vancouver in terms of WTE.
And thank you guys so much for watching our YouTube video.